I have been working quite a lot with the viruses. Basically, everything I do is around the viruses. There isn't anything else that I know about any other pathogens like bacteria and parasite. So, since the COVID-19 start, I developed the COVID-19 diagnostic platform, which is artificial intelligence guided, and it has now been approved by the MHRA. It is being rolled out not only in the UK, but around the globe, and it's a 20-minute, very fast, accurate, economical, can be done in offices or on the bench top. Beside this one, myself have developed one of the very few COVID-19 nasal vaccines that can be administered through intranasal route. And basically, we have had few glitches in the beginning for funding, but this has already completed its preclinical stage. And in next 1 or 2 months, we will be moving toward the clinical stages of this development. Just to mention that I sit onto the WHO expert panel onto the animal models and vaccines. So basically, any information that come onto the public pass through our panel, and we meet fortnightly to discuss all the progress going on with the vaccine. Probably some of you know me that I've been speaking onto the media quite a bit. It's pretty overwhelming sometimes, but it gave quite a good opportunity to engage with the general public and really answer the question that required clarification based on the scientific data, not based on what is out there onto the media outlets. So to begin with, I would just like to emphasize onto the fact that the vaccines are extremely important. Some people have always the question that whether do we really need vaccines or not. I think this slide is going to give you a broader perspective why vaccines are so important. For example, if we talk about last century, any year, you will call about the measles, pertussis, mumps, rubella, smallpox, diphtheria, and polio, any disease you can think about in the last century. But since the introduction of the vaccines, these diseases have come to ground, literally, and more than 99 to 100% reduction in the disease has been reported. Since I'm originally from Pakistan, I know at least 10, 15 people within my family that have a polio paralytic form. But when we talk about current scenario, the polio is almost negligible. And what it has happened is just because of the vaccines. There isn't anything other than that. Similar condition with the measles. It's been significant reduction, more than 99%, and all that has been achieved through the vaccination. There isn't anything other than that to count on. But when we specifically talk about the COVID-19, I would like to emphasize two things: that antibodies and T cells are very critical for the immune responses to mount. And until any of the vaccine would not really cover the antibodies and T cells, that vaccine wouldn't work. And how does that happen? Just to give you a little bit of background, the virus enter through the nose and mouth. Once it's entered into the upper respiratory tract, it has to replicate into the cells. And this replication is critical so that the cell that is infected with the virus to be presented with some of our immune cells. And one of them is antigen presenting cells, macrophages here. And these are then converted into different immune cells within the body. And one of them is cytotoxic T cells. And those T cells are absolutely important to kill any cell that is infected with the virus. And these are the ones that are converted into the B cell and that produce the antibodies. So all in all, the antibodies, those are produced by the plasma cells, and also the T cells, those are produced by that are primed by the macrophages, and antigen presentation are critical for the success of any vaccine. So when we talk about major vaccines, what we look into, how much is the antibodies are produced in a person who is vaccinated, and how much as a T cell responses. Looking onto the major vaccines, most of these vaccines do produce antibodies that can neutralize the virus, and also they can induce the immune cell, particularly the T cell responses, which mean they are pretty good in protection against disease. But then the safety is another concern, which we will run through. Briefly, I want to talk about the AstraZeneca association with the blood clots, which is, I think, everybody is talking nowadays. Is that the blood clot is pretty common condition, which is not really something that could have triggered an alarm in a trial, because the trial was conducted in relatively smaller population. So when it come into deployment, that is the time when you are going to pick up the rare event. And the event is that a possibility, their clear possibility is that when vaccine is injected into the person, immune responses kick in, and that immune responses deplete some of the platelets, which are the critical factor for the blood clotting. And one of the blood clot is the CVST, which could occur in brain and can lead to stroke. And that is one of the major concerns with the AstraZeneca at the moment. But just to give you a scenario, you don't need to be alarmed with the blood clots and the vaccine itself. The reason is that if we look onto the German data, for example, they have vaccinated 1 million people. There have been 12 clots and only 4 deaths. So that is the condition with the blood clot and the AstraZeneca vaccine. But when we really look into the other scenario, and that is to get the COVID-19 instead of having the vaccine, then around 20,000 deaths could be expected from 1 million COVID-19 infection in over 60s, and in 14 is still 1,000. So up till this age, it is more advantageous to have the vaccine than to get the COVID-19. But that is really the question that we can discuss when we go through in the question answer section, whether the AstraZeneca vaccine is still safe. The slide that was presented today in the press conference is really elaborative, and this tells you how much is the potential benefit of using a vaccine and how much is the potential harm for using a vaccine. But the thing that came up as a revised strategy for the vaccination is this one. So basically, the possible risk with the vaccine to get the blood clot versus the benefit you will get avoiding the infection is almost in parallel. So there isn't much advantage in this cohort of people. So therefore, it is suggested that below 30, the vaccine will not be used. But if we look onto the other age group, it certainly makes sense to keep using these vaccines, particularly because of the concerns that we don't know much about this virus and this disease in a long-term perspective. One thing that I always like to say is that we are talking about the transboundary infection, the infection that does not respect any border. This means that if the disease would be lingering on in any country in deep pocket of the Africa and Southeast Asia, the disease would still be a threat. And how would that be a threat? Because the vaccine deployment is very critical. And unfortunately, at the moment, we have seen only the rich countries are the one that are receiving the vaccine. And this short animation will clearly tell you that most of the vaccines are currently being deployed in the countries those can afford it, whereas the cycle indicates the potential deaths within that population. So you can see, although there are more deaths in countries like India or Pakistan or Southeast Asia or in Brazil, but these are not the ones that are getting the vaccine. Vaccines are administered by more countries. Those are in a richer context, and here are most of the European countries. And why that is important is because until we don't really reach to 75% of the world population, we are not going to see a significant impact of the vaccine, and that would require certainly at least 5 to 10 years going into those countries which cannot afford. The countries who cannot afford are being offered by COVAX facility. COVAX facility is set up by the WHO, CEPI, and Gavi, with the UNICEF and along with the Bill Gates Foundation funding. They promised that 20% of the low and middle income countries would get the vaccine by the end of 2021. But unfortunately, they run out of the funds at the moment. They are deficit with 3.2 billion US dollar for the vaccine supply. And then there are other logistical challenges. For example, the COVAX will only deliver the vaccines to the airport, but after that, administration, deployment, cold chain facility all need to be maintained by the country. And if they don't have the infrastructure, the whole COVAX seems to be pretty pale. So just to put everything into the context, what we know is that the vaccines that are being deployed, we don't yet have a very solid data that indicate that people would be protected from infection after getting the vaccines, or will have a transmission blockage, so they can still be able to transmit the infection even after vaccination. But what it does, it protect from disease, protect from the severe disease, and also protect from hospitalization and death. But long-lasting immunity, we don't know. The only study that we have received results from is just last week, indicating that the immunity lasts only for 6 months. But my anticipation, based on other coronaviruses, that it might be more than 2 years, but not more than that. We don't have yet vaccines for many other cohort, like children or the pregnant women, that also contributing quite significantly into the disease transmission. So until we don't vaccinate children, probably we are not going to have a good handle onto the pandemic. Herd immunity is something that we don't really know if the current vaccines are going to provide or no, but there are future variants, those are going to emerge, and those can evade the immunity. The last slide I just want to say is that probably we are taking the wrong approach to immunize the world population. The reason I always been saying is this, that virus enter through the nose and mouth. Until we don't really block up here, we are not going to really block the entry of the virus, and the virus carry on entering. Doesn't matter how much is the immunity, either the mutant or some version of the escape would be there, and that would be posing a risk. That was the reason that I started developing intranasal vaccine, because we thought that that is probably the appropriate route. And based on our preclinical studies, it appeared to be that if you administer the vaccine through the nose, basically you are priming the mucosa, where the all of the immune cells that I describe here, they are going to produce the antibodies and the prime onto the right side where the virus enter. And that was the reason that if you look on here, the vaccinated animal, we did not find any of the virus that was challenged into those hamster or the model that are used for the vaccine evaluation. So all in all, what I wanted to emphasize is that until we don't really have the intranasal vaccine, probably taking the control of this pandemic going to be very grim, and deployment into the whole world need to be done at a certain scale before we really claim any victory.